So in between 3 to 4, I'm.
Go, no problem, no problem. Good morning, folks in class and our virtual learners. We are back again. Last night we have done the inerting of the line of the tanks, and we have used the displacement method, which you are currently looking at the moment now, that we were starting our inert gas generator, taking it from the liquid header, putting it down, and from the air we were purging out from our ventilation header through the MoS riser. So this is so far we have done, and at the same time after that we have inerted the lines also. So now in our next exercise, our whole vessel will be free of air or oxygen in our system, where we are ever going to take the gas. Now, so far we have done the preparation for loading after the dry dock, means removal of debris, testing the equipment, testing the systems, and then we had gone in the phase of drying up the tanks and lines. So we have dried up the tanks and lines. We have put the nitrogen in interbarrier spaces and other places where nitrogen is required. We have fed the nitrogen to different parts wherever it is supposed to go. Now our nitrogen generator is running, and we are maintaining the pressure in the system through the buffer tank. So our nitrogen generator is working on automatic mode. If the pressure drops, it will automatically start refill the buffer tank, and buffer tank keeps supplying the tank. So next step, just before going to the next step, I want to make you clear that the method which we have used yesterday was the displacement method, which is relatively faster method. It saves our time. Now, what we want to show you also, that there is also a dilution method. This is the dilution method. We are starting our inert gas generator, although we haven't used it on our system yesterday in order to do it fast. But here we are sending this down from the spray headers and taking it out from the bottom lines and pumping it out, or giving it to the vapor header to the MoS riser. But again, I've told you yesterday that this will take a very long time. We will have to run the generator for a very long time, and of course displacement is comparatively the better method if we have got the lines available, and we can also monitor it very clearly, because always in a displacement mode we have reasonably clear interface between the inert gas and the air, and vice versa. So let's press on to our next subject after the inerting. Now we have no air, so we are sure that there is no air in the system, so we will never ever go in the mode of gas explosive environment. Now, the class learners, can you tell me what do you think the gassing up is?
Gassing up with nitrogen.
Yes, I agree. Gassing up
Gassing
with
up
nitrogen or
like inverting the.
Yes, we have done nitrogen work, isn't it? We have started the nitrogen generator, we have put in interbarrier spaces. You remember we have even given it to the compressor, the nitrogen and all that.
Gassing up is.
Now, this is the first time you are going to put the hydrocarbon gas. Can we put liquid inside the tank? No. Why? Because my tanks are on an ambient temperature. My lines are on an ambient temperature. If I will introduce liquid of minus 161 degree, it is not going to it is not really going to benefit it, because it is going to give the tank the thermal shock, the lines the thermal shock, the metal contraction will be so fast that it may break or the joints may open. Okay, so we need to do the gassing up. Gassing up is a why to gas up. Tank will be cooled down below dew point. We will first gas the tank at an ambient temperature. Then slowly we cool the tank. That is called the cooling process. And then dry ice deposition of CO2. Ig contains 15% by volume and occurs at 78 degrees centigrade. This is the biggest problem. Minus 78. Now what you have done? You have removed the oxygen from the tank by putting in the inert gas. But now what you have done is that you have put in the carbon dioxide. You remember we were checking the carbon dioxide from our portable detectors yesterday in our tanks? And the carbon dioxide from 0.4% have risen to nearly 10%. So that is an undesired situation, because what will happen if we straight away give the cool gas to the tank? The cool gas is going to sublimate, it is going to become ice. Suddenly imagine minus 162 you are sending in the tank, it is diffusing, giving a very sharp cooling effect, and what will happen? All the carbon dioxide will shower down the tank like an ice crystal. You will have a snowfall in the tank. Okay, so I hope you are imagining this thing clear. Did you get my point? Yeah. Okay, so gassing up is technically a process of replacing inert gas with methane gas or CH4 or LNG. In Ng in the gas form, not LNG. Inert gas contains uncondensable gases. This is the problem, because if the inert gas, if we are running the compressors, compressors will have a very hard time, or the liquefaction plant will have a very hard time with the inert gas. So we want to get rid of these inert gas, every single, possibly every single molecule of it, so we will have no problem in reliquefaction plant. Okay, because some of the gases in the inert gas system will never condense, or we call them uncondensable mostly under the normal conditions. Everyone thing can be condensed. Nitrogen and CO2 cannot be condensed by the ship reliquefaction plant. Okay, so this is the problem. And venting to atmosphere is subject to Marpole Annex 6. I'm not going in detail. You have got the material. You can read it. So return to shore until the tank with full next cargo vapor.
Nowadays, every shore facility has got this return to shore.
Yes, yes. Most of the time, the ships have got this. The terminal have got this arrangement. But this thing, the gassing up process, the cooling down process, the inerting process, nitrogenizing process, you only do it when you come out of the dry dock once every 2.5 years or 5 years, you know. So it is not very often. Rest of the life of the ship is just simply going, maybe cooling the lines, if required, cooling the tanks, and simply loading and going away. Okay, so this process is not very often done, but there are certain companies who have made the barges. Hmm. These barges are placed, I'm aware of some of the Far Eastern countries, and as soon as the ship comes out the dry dock, the barges comes alongside, and they are the one who assist. They have the liquid gas, LNG in them, and they will provide all liquid gas and other stuff to the vessel, and the vessel will be ready to load cargo, almost ready to load cargo, which means um, oxygen out, inerted, inert gas out, gassed, gassed, replaced, or gas further cooled down for loading. Okay, so this is sure. So in our exercise, which we are going to do next, we are going to use the return to shore method, where we will be giving our inert gas to the shore, and we will also maybe give the other mixture of the gas and hydrocarbon gas and the inert gas. Many terminal, if they have separation facilities of gas and inert, and then it is okay. I have observed some of the facilities, they just flare it up. Of course, in the beginning, only part which they really have to flare it up is the middle part, where you have, the hydrocarbon and the inert gas interface, that where you have got moles of methane and moles of other gases are mixed together. Okay, so gassing up at sea only available to fully semi-pressurized vessel, often with dead tank. Okay, so on your bunker barge you may have this kind of facility, or the gas may be provided by a portable containers or something like that. So the industry is evolving. The ship owners, the barge owners, the other, they have two objectives mainly: save money and save time. But no one compromises the safety. So industry is evolving. They are finding the methods by which they can save time and money, and of course make the operational as safe as possible. So before commencing gassing up, O2 contents of the tanks should be less than 5% by volume. Yeah, we definitely want that. We prefer it to be much lesser, even couple of percent. So once we started the process of gassing up, even before touching the shore, what I will ask you when the exercise will start, please go and check the gas, check the O2 content on different levels of the tanks. So then you will be able to be sure that there is no oxygen in the tank. Because if there is oxygen, we need to inert it more to make sure that no part of the vessel, even the pipelines, our equipment, machinery, tanks, ever go to a point where there is an explosive range or right mixture of oxygen and hydrocarbon are there. So compressor for reliquefaction can be started after gas connection into the tank reach at least 90%. Okay, so in the next exercise, what we are going to do, we are going to do the testing of our environment in different positions through portable gas detectors. Then we are going to do an hot ESDS test, which I'm going to explain a little later. Okay, so any questions so far? No? Let's move. So what we are trying to achieve in this gassing up? This is an explosive range diagram. The lowest level where we think the LEL is below 5%. So in the gassing up process, what we are trying to do is to bring the oxygen level from 20% to this percent. We have already achieved that by replacing the oxygen with the inert gas. Okay, so gassing up now is something like this, a very sharp process. So how do we gas up? We have our ship tank, which is filled with inert gas. We have got a shore tank, which is filled with liquefied natural gas and the bit of vapor. Do you think this vapor is enough for filling our tanks, 5 tanks, 4 tanks?
No.
No. So what we will have to do is that either they create the vapor through vaporizer and give us the gas, or we take the liquid from them and we vaporize it, make it to the right temperature, put it in the tanks, and keep on cooling it down. Initially we will be putting in the gas at more or less the ambient temperature or just below the ambient temperature, and slowly and gradually while we are gassing up, we will keep reducing the temperature. Okay, so this is what we are doing. We will ask them to pump the liquid from the shore. It will go up to the Chickson arm, up to the Chickson arm. Can I see? Up to the Chickson arm, and then we will pass it through our vaporizer. We will give steam to the vaporizer, and then we will get it, of course, we will put it in our tank. Now, at this instant, I want to ask you where we are going to introduce our gas, from the top or from the bottom?
So from the bottom.
From the bottom. Why you are doing it? Yesterday we have put the inert gas from the bottom, isn't it? Why we have done it?
So that it gets into every part of the tank.
And why we have done it? Because you remember the name yesterday? NaIL. Nitrogen on the top, lightest. Air just below it. Inert is heavier than air. And liquefied gas or LPGs or etc. Mind that methane below minus 100 degree is heavier than air. Okay. And above minus 100 degree, it is lighter than air or inert. So we are going to put our our LNG from the top in the vapor form.
Okay.
Okay, this is you will have to remember, because when this gas comes here on the top, it is simply pressurize the inert gas. There will be a clear interface here, and the inert gas we can vent off or give it to shore.
Okay, sir.
Okay? Um, um, okay, are we clear on that?
Yeah.
That's why we are doing it from the top. Inert gas, because inert gas was heavier than air, we have put it from down and taken it out from.
Yes, sir.
That is the reason why we. Okay?
There's a difference between oil chemical tankers and LNG.
Yes. You folks who are working on oil and chemical tankers, sometime
Yeah.
you have difficulty because actually you will have to wipe up your old training and then take the new training of balance. This is the many principles are same, but some of the principles are different. This is why the LNG operations are thought to be a little complex because you are handling something which you have not seen at all. In an oil tanker, you see something is passing, something you take out the samples, you check how the quality, you do the different thing. You can even open the lid and see the cargo. But here you are loading, discharging at the same time so many different things. But you will never see any one of those, isn't it? The only thing is your pressure, temperature, you are playing with, and of course your liquid levels. So, and the maximum thing which you will ever observe is the frosting on the lines. That is, or cooling off the line. Other than that, you will never see cargo, you will never see inert gas and all that. Mm. So, folks, this is the process for gassing up. Mm. So, gassing up. Inert gas. Methane enters the tank through the vapor line at the top of the tank and exits through the liquid filling lines to exit through the vapor filling lines to this. So this is what we are doing, throwing the LNG and pumping it out. Now, this is something which I want you to note down, that our maximum temperature could be, we can give outlet temperature of the vaporizer should not be more than 80 degree centigrade. Why like that? Because most of the pipelines have got polyurethane or foam type material on it, and they melt around 100 degree centigrade temperature. So we do not want to heat up our lines where we may be damaging the insulation on the pipes. Mind that if insulation melts, the thermopole type or that will create a gap in between the pipeline, and that gap could be have an icing on it, or frosting on it. Minimum temperature initially plus 10 degree. Why 10 degree? Because you will notice that the place where we are doing it, berthing, has got an atmospheric temperature around 20 degrees. So we want to reduce the temperature to initially just 10 degrees. So there the thermal gradient in between these two are 10 degree, which is acceptable. And at the same time, we are giving a slight cooling effect to the tank. Mind that when we are cooling the tank are shrinking. It is going through a big stress where the size of the tank shrinks because the tank is expanded in the ambient temperature plus 20, and you are taking it to minus 162 degree temperature. So it is going to be shrinked quite a lot. So compressors, motor room arrangement, this is our arrangement. IGC code 10.2.4.2, you can have a look in the IGC codes, folks. and 2.4.3 give us the gas tight seal through the bulkhead, which is this requirement. The one side there is a positive ventilation and the other side negative ventilation. Can you see here that the pressure is built up here and there is a positive pressure. This is the room where there are electrical panels, where there are electrical motors. We need to keep this environment clean. No hydrocarbons should ever come here. So we have an airlock system where technically you open the door to enter. Okay.
Airlock doors. Right?
Yeah, airlock door.
Gas tight doors.
You gas tight door. You close this door, and only then this door will second door will open. So means in this process, if anything, because this is under high pressure or positive pressure, the fresh air will go out, and no hydrocarbon from deck can come inside. Are you getting my point? And vice versa, compressor room, negative pressure, suction from the top and from on the bottom. So here again, because there is gases here.
To enter these rooms, there would be a proper procedure to get into, like.
Not an enclosed space procedure, but it is if your company or organization is considering enclosed space, then yes, you can have procedures for it, and normally this is like you are entering your engine room. So there are trips for non-approved electrical power laws, etc., etc. So this is something which is in the gas dangerous zone. It is on the deck where there is a possibility of gas. In fact, the compressors are running here, right next on the other side of this bulkhead. There is gas, isn't it? So you have to be very careful here. So do you understand the compressor and motor room arrangement? Now, let me move on. This is the bulk heavy duty compressors. This is the motor. I'm thankful to Cryostar who we have used their picture here in order to explain you. And this is the shaft. This is the seal arrangement running the compressors, the vanes, etc. And we have got, the compressor at what RPM they are running?
9,552.
Yeah, 9,552 RPM, nearly 10,000. It's a very high level of RPM. This is a kind of air seal. Can you see, remember, yesterday I have given nitrogen to the compressor. So this is a nitrogen seal. Beyond that, there is hydrocarbons, okay, which is getting compressed and pushed away, okay. So this is really dangerous area. Nitrogen is a buffer kind of zone between these gearbox and etc. There is a cooling liquid here, cooling or heating both, of course, which is maintaining the temperature, because if we are getting too much cold gas, it is going to maintain the temperature here, so there is no frosting happening here. And of course it also need to keep the lubricating oil going. So this is the actual compressor. Here the compressor these are the vanes. This is the angle which you will change on the simulator. All these different systems of cooling, nitrogen supply, etc. So the gas comes in. If you let it run on a no angle, there will be no gas movement, although it is running at 10,000 RPM. It is like a fan angle or propeller angle. If you do not give, if you keep a variable pitch propeller on zero pitch, it is not going to move anything, isn't it? So the vanes we will have to set to, and this experience you will get today in the working here. Now this is the same vanes. Now they are. It is exactly like an aeroplane thing.
Like gas turbine.
Gas turbines, aeroplane turbine. Can you see these points?
Yeah.
These are the one, and you are controlling this from excuse me, from the simulator. So please be very careful when you are operating this thing on a simulator. Don't assume that it is just a video game, or think what is happening behind it. So do it very gently. These are some inlet vanes, other ones where you can see different angles on different vanes. So, and of course, every mechanical thing is outside. Very simply, it is just the blades which are inside. So, in line with shaft, 0 angle. Okay, 0 degree, and this is about 80 degree maximum. Minus 30 maximum. Okay, this is some parameters of our HD compressors, alarms and trims, because this is what you are going to use on a simulator. Low boil, low temperature, 90 kPa. Nitrogen seal 10 kPa. Low boil inlet 65. High temperature. If low boil is more hotter than that, of course it will start evaporating. So excess vibration 80. It will trip if the vibration goes too high. That is why you give it very slowly, so you don't instigate any vibration. Discharge gas temperature maximum 100 degree. Even we will never go to that. It will trip. Bearing low boil temperature 105 degree. Rotor axis plus minus 2 millimeter, 0.2.
Bearing low boil temperature is quite high. 105 degrees.
105. Reason being that is the trip point.
But normally, how much do we keep in the?
Normally below 80. Below 80, because anything above 80 is not good for us, because it may damage our insulations. Okay. So bulkhead seal high temperature 120 degrees centigrade, and of course bulkhead seal pressure 3 kPa. This is again differential pressure, vapor head pressure 0.3 kPa, and interbarrier pressure header is 0 kPa. I'm not expecting that you will learn everything today. It takes a long time, but the project objective is to give you the understanding, the practical on-hand experience on this vessel, and our virtual learners are also able to see what you are doing here, or what we are doing here. So at least they can visually observe you, and of course if they want, they can ask us the question. So this is the cofferdam. This is the NO96 model, which I am going to give you today, because yesterday we have done Mark 3 model also. So I'm giving you the experience on almost all the different models. So these are the cargo tanks. In between there are buffer tanks or cofferdams.
So what are these red and green line in the copper?
These are, the main line. They maintain the temperature. The other side, it is very cold.
Okay.
And we do not want this to be, very hot, or, So we are just maintaining the temperature in it. Yeah. So cofferdam heating. This is the Mark 3 system, where you are getting the heating inside the cofferdam. Otherwise, everything will freeze. In that there will be frosting happening in it. It's like the mister of your glass, car glass, at the back.
Yes, sir.
You do not want, this thing to be. Sometime we have a possibility that we can put an nitrogen gas altogether. Uh, so actually it is the glycol water which is just moving around. And with this glycol water, we are just maintaining the temperature. And this is a cargo motor room glycol heaters which are heating it, or from motor room glycol heaters. So, to and from this place. Now, come to the business. Gassing up, we have a choice that we can take the vapor from the shore and vaporize it or gas up. But if we are not able to gas, we will take the liquid from here, pass it to the vaporizer. Vaporizer we vaporize, and then we give it to the tank, and from the tank we give it to the shore. We will not give it to the environment because of course emissions control. Now you will be seeing very interesting thing, which is the heaters and vaporizers. This is one of the vaporizer. Can you see this line here? This is where the condensate will be collected.
There's a gauge also.
Yeah, and this is a liquid level gauge. Can you see it is also here? This is also visible on your simulator. Okay, I'm going to explain you the principle of it very clearly. That if the liquid goes more than 140 millimeter, the system will stop. Okay, and it will trip. Actually, it is the steam which is going in, hitting it. So if anything, the liquid condensed will be collected here. So what we will have to do is we'll have to open the valve and drain it. You can see the drain. So this valve I am going to show you time to time. Keep an eye on it and keep on draining it. Okay? So this is the vaporizer. How it works, I'm going to explain you in a little while. To vaporize a liquid for gassing up, the operation of purging inert gas from the cargo tanks before introducing cold liquid. So during cargo discharge, if no shore vapor return line is available to make sufficient vapor from the liquid cargo to prevent formation of vacuum in the tanks. Yes, you are loading when you are discharging the cargo. Your tanks are getting empty. If you do not fill vapor in it, it is going to collapse inside, isn't it? Going into vacuum and collapsing. So we need to have vapor. Many good ports we will get the vapor from the shore. But sometime we will have to generate on our own vapor. And that is what vaporizer is doing. On a bunker barge, the pressure type vessel, we are discharging by creating our own vapor and putting it back into the tank, creating a pressure inside the tank, pressing the liquid, so the liquid will go automatically for bunkering. Okay? Means we are not using pumps or anything like that. It is just, pressing from the top, so it will go out. So that, if we maintain, if we manage that pressure, we can manage the flow of liquid. So no physical cryogenic pump is required for pumping or for bunkering. But only by pressure we can manage it. And on the other, and that is where we do not want any vapor to be coming to us from the shore. The bunkering video, which I'm going to show you, which we have got for this project, courtesy to Viking Grace people, that we are able to, do the bunkering with one line only. No vapor return line. Just the liquid line. Connect, give the liquid to them, and that's it. Of course, they will have a very high level of vapor. So On the Viking grade, they have an arrangement that they can reliquefy or consume it in their engines or boilers, etc. So we also use it to vaporize liquid nitrogen for purging cars. When we purge before going to the dry dock, we can purge it by the nitrogen. Because nitrogen purging is faster, very pure, but the ship owner can supply us liquid nitrogen before going to the dry dock, and we can take that liquid, vaporize it, push it into the tank, and push out the hydrocarbon. Are you getting me? So as a vaporizer itself is a backup of forcing vaporizer also. Forcing vaporizer, we are normally using it for our, supplying the boil of gas to the engine. So LNG vaporizer, this is how it is working. Courtesy to CryoStar again, that we have got the liquid coming in here. Liquid is passing through these lines, getting heated and going away. Now, how we will maintain the temperature? Because steam can vary. Steam is coming in, steam is going out. So steam temperature can vary, or your liquid flow can vary. So maintaining the outlet temperature is very difficult. So what we will do, we will have a bypass liquid line here. If we have got too high temperature, for example, initially I just want 10 degree temperature. I do not want 50 degree temperature. So what I will do, I will spray it here and maintain the temperature. So this valve can be controlled automatically. If we set the temperature here, okay, plus 20 I need. So whatever is coming out would be plus 20, because if it is high, it will just give a little sniff or little liquid in it, and it will maintain the temperature. Are you getting me? So it is kind of dosing the liquid. And this is the steam chamber, and I will show you the coils in a minute. There you go. So, folks, now you are able to see the coils. Okay, this is your gas chamber. This area no gas will come. Only the gas will go in the tubes. All the tubes from the bottom go, get heated, and go out. Happy? This is same thing, and now we have opened. This is again the vaporizer, the same vaporizer in detail. Shell, we are now giving head, we call it head. You may have noticed that we fix this thing from here and we leave the other bit nearly suspended for expansion. This is your tube plate, very strong plate, inlet chamber where the liquid is flooding inside the pipes, U-tubes for taking it out. So why we are using U-tube? Can you tell me?
The edges have got more stress.
Okay.
So the U-tube.
Okay. And can we take a few minutes break? Speaking.